Hi, welcome to Chapter 4, where we are going to be talking about rational expressions and equations all chapter long. In this first lesson, we are going to be simplifying, adding, and subtracting rational expressions. Sorry, simplifying, multiplying, and dividing. That's what I meant to say. Okay, let's start out. We are with a little bit of vocabulary. I want to start by defining rational expressions, what it means. So rational, first off, is just a really fancy word for fraction. That's it. And an expression is anything with a variable or a letter. So this chapter, when we're talking about rational expressions, we're talking about fractions that have variables in them or fractions that have letters in them. So for example, looking at this first one. So the first thing we're going to learn about rational expressions or a fraction that has letters in it is how to simplify them. Now this is actually very similar to what you did in elementary school when you simplified fractions. For example, in elementary school you may have given a problem like 4/6 and your teacher may have said simplify this. You probably came up with 2/3 without too much thought. Now let's talk about what actually went through your head when you came up with that. Now, many of you probably did something like this, where you said, well, 4 and 6 are both even, so I'm going to divide them both by 2, and that gives you your 2/3. Well, another way of thinking about this is if you kind of separate these terms. So I take this 4, and I say, well, I know 4 is 2 times 2, and this 6, I know 6 is 2 times 3. Well, I have a 2 on top and a 2 on bottom, so they can cancel each other out, and now I'm left with that same answer, 2/3. So those are two different ways of simplifying that you may or may not have been taught. This second way is what we're going to be focusing on, meaning separating it as much as we can and then canceling stuff out on top and bottom. So for example, let's look at this first one. 21 is 3 times 7. So I'm separating it, kind of like a factor tree from elementary school. And a cubed is a times a times a. So there we go. I've completely separated the top. Now let's look at the bottom. 7 doesn't factor tree, so I'm just going to leave it as a 7. And then I have a cubed again, so a times a times a. Now I have a 7 on top and bottom, so they'll cancel. I have a pair of a's, they'll cancel. I have another set of a's and another set of a's. They'll all cancel. So the only thing I'm left with is 3. So that's my answer. That's simplifying that fraction as far as it will go. We can do the same thing over here on example 2. So I'm going to take this 18, I'm going to factor tree it, so 2 times 9, and then 9 is 3 times 3, so 18 is 2 times 3 times 3, and then it's d squared, so times d times d. Now, this bottom one is a little different, and here's why. This is the first example for this lesson where we have an addition or subtraction sign. Now you can think of that addition sign or a subtraction, if it's a subtraction, as glue. That addition sign is going to glue the 4D and the 8 together, meaning that if we're going to get rid of them, we have to get rid of them together. We cannot get rid of them individually or separately. That plus sign is glue. So whenever you have a glue term, is what I'm going to nickname it. So right here we're going to call this a glue term. Because it has that plus or minus glue in it. Anytime you have a glue term, you're going to want to check for GCF / factor it. I'll do and or. So I'm going to see if I can take a GCF out of that. And I can. They have a 4 in common. So I'm going to take that GCF of 4 out. And if you remember, whenever we say take out, we actually mean divide. So 4D divided by 4 is a D, plus 8 divided by 4 is a 2. Now I have a new glue term. So something I want to talk about with this glue term. Because this D and 2 are glued together, I cannot cross this D with that D. That does not work because that D plus 2 is glued together. So if I'm going to get rid of it, I have to get rid of them together. Now some of you might be saying, okay, well let's get rid of that 2 and that 2 and that D and that D. I got rid of them together. They're all gotten rid of. Once again, that doesn't work. If you're going to get rid of that D plus 2, you have to get rid of the whole thing. So if there's a D plus 2 I want to get rid of, there has to be a D plus 2 on top that I am also getting rid of. And we'll see that in the next example. So I cannot get rid of that 2 or that D in that glue term. However, I'm going to rewrite this problem. I can break that 4 down. I can factor tree that 4 to 2 times 2. Now, you'll also notice a little thing I'm doing. I am putting parentheses around my glue term. It's a good habit to have. Anytime you have a glue term, put parentheses around it. So then that reminds you, if I'm going to get rid of this, I have to get rid of the whole thing. Everything that's in the parentheses. Well, now that I've broken up that 4, I can get rid of those 2's because they don't have a glue term with them. So now I'm left with 3 times 3 times D all over 2 times D plus 2. There's nothing else that I can cancel on top and bottom, so I'm just going to simplify that. 3 times 3 is 9. D times D is D squared. And this I can just leave factored out like that. And that's my answer. Okay, let's do one more example on this video. This is an example with glue terms. So on this one, I have a glue term on top and on bottom this time. So remember, anytime we have a glue term, we think GCF and or factor. We can only factor it if it's going to have something squared. Just so you know. This one doesn't have anything squared, so we're not going to be factoring in this one. We just need to check for a GCF. Well, there's no GCF on this top one, so I can leave that. This bottom one has a GCF of 3. So I'm going to take out or divide both of those by 3. So now I'm left with this. Now, like you can see here, I have a glue term on top that matches a glue term on bottom. So once I have glue terms that match, then they can cancel. So my final answer, I have a 3 left on bottom. I don't have anything left on top. If you don't have anything left, it's a 1, not a 0. That's a very common mistake that I see happen. Okay, so those are our first couple examples of simplifying. In the next video, we'll do a couple more examples of simplifying, and we'll do some ones that we need to factor as well.